Now we are going to write an LMC program that outputs the sum of n numbers of the input values. So we need two input, or maybe more than two input, but one input is for n, that is the number of values we are going to enter, and then the remaining set of values which we want to add it up. So that's why this is the logic for coding that. So we'll take first of all the input of n, that is the number of values we are going to be adding, and then we'll be maintaining the sum. Then we will keep asking for one by one each of these values. That is all the time called x. Every time the x is entered, we add it up to the sum. And then we reduce the counter. Why do we need to reduce the counter? The reason is from 5, we are expecting now only 4 values to be entered. Once the fourth value is taken, we are expecting only 3 more values to be entered. So that's why the counter is maintained with the help of n. Thereafter, we check if the n has reached to 0, then we should stop. Until that, we keep asking for every time the input, add it up to the sum, reduce the counter, and continue to check if n is not reached to 0. The moment n is reached to 0, we want to give out the output, which we are maintaining all the time, that is sum. Therefore, it is very clear that we need to have a data value stored for n, x, the sum, and the n. So these are the values. So now let us start coding it. So we start with our LMC IDE and we go to the new one and consider that this is the new file. I may save it and I give it sum of n. All right. And then we start coding. So we are taking first of all the input of n. So that is input n. And then we need to check. So what happens is that it goes on for 0. So 0 is included. So if we want to take 5 values, we should say 0, 1, 2, 3, 4. So in that case, we may have to reduce one value because it goes till 0. So that's why for a logical operation, I want to subtract. But I don't have the values to be stored anywhere. So first I will write the hold, and then I will write the data section. So I'm defining n first. And then I'm maintaining the sum with s. Then I want x. And then I have n, which I will name it m this time. So my data section is ready. So now I can use it as and when required. Now m is the one which I am defining its value as 1. The reason is I want to reduce 1 every time from m or any other value. Now we subtract m from whatever is taken is lying in the accumulator. Then we can store it in the n. So now we know exactly if 5 values are there, 0, 1, 2, 3, 4. So it is lying at the 4. Thereafter, we are supposed to take the next input, and that we have to maintain because you can see here that that arrow is going back. So we should maintain a label where we can come back here. So that is input. And now I'm going to store it as x because this is input x, right? Now we are supposed to also maintain the sum, but we have initialized sum to 0, right? But what is in the accumulator just now? X. So we cannot add X to something. We are actually supposed to add and maintain the sum, right? So what we are going to do is we are going to load the sum value, and then we will add the X value to it, and then we'll store it back to our sum. So that's how it is converted. Now, next step is maintaining n. So for that, if we want to reduce something, first we have to have it in the accumulator. It is not lying in the accumulator. So first we load the n value. And then we subtract 1. Where is 1? Which is in m. That is -1. And then we are going to have update it in the storage by storing it back to name. Now this is also done. So now we are here. We want to check the condition. Now what is in the accumulator? The value of n, right? So we need to check if it is 0, right? So BRP, if it is positive, then take the input, that is INX, right? Isn't it? So here we are going to have it INX, take the input. If this is not true, that we are supposed to give out as an output. So for that, the control has come here. Then we load the sum, and then we out, and then we halt. So all other things are done. So let's cross check with our logic. We have taken the input n, and then we are maintaining the sum. But first of all, we have to subtract 1, right? So that we can maintain the minimum value, and then we store it to n. We have taken n. Now the top part is for taking the x. We take input x, and then we store it in the x. Then we load the s, right? LDA, load s. And then we add x to the sum. And then we store it back to the sum. Then we load n. And we deduct the 1 value minus 1 value. And then we store it back to n. After that, we are going to check if it is positive. If it is positive, then you transfer the control to INX and take the next input. If it is not, load the sum and give out the sum. And then hold. So this should work. So let us check it. So first value, we are giving 5. Suppose 5 elements we want to enter, right? So then we are giving the first value. Suppose I am giving the value 1. And then I'm giving the value 2. And then I'm giving the value 3. And then I'm giving the value 4. And then I'm giving the value 5. So 5 plus everything, 5, 4, 3, 2, 1 total becomes 15. And that is the output, which is also maintained here all the time, right? And now n value is -001. See, so that's why it stopped the execution. So this program is working fine and everything is done.